Okay, so today in this video we are going to see how to solve an LPP by simplex method. The question is given, solve the following for LPP by simplex method for optimal solution. Max z equal to 8x1 plus 20x2 subject to constraints 2x1 plus x2 less than equal to 80, 3x1 plus 4x2 less than equal to 96. The first step in simplex is called standard form. In standard form, what we do is we convert both the constraints in equality, and we introduce one extra variable in that. That extra variable is represented by s, and that is called a slack variable. So we will introduce one variable in first constraint and one variable in second constraint. So it will be like 2x1 plus x2 plus s1 equal to 80, and same way in second constraint 3x1 plus 4x2 plus s2 equal to 96. So this s1 and s2 are called slack variables. And then same way we will write again the objective function, and that objective function will be now max z equal to 8x1 plus 20x2 plus 0s1 plus 0s2. Now why this 0s1, 0s2? Because slack variable does not contribute anything to the profit. See, max z means what? Profit values. How much is the profit value of x1 per unit? 8 rupees. For x2 per unit it is 20. But for s1 and s2, their profit contribution is 0. That is why in the objective function we have written here as plus 0s1 plus 0s2. What is the slack variable? Slack variable represents unutilized capacity of a resource. So for example, if this is resource number 1, whatever capacity is utilized, that will be okay, and whatever remains unutilized, that is represented by s1. Same way for second constraint or second resource, whatever capacity is not utilized, that will be represented by s2. And since it is unutilized capacity, that is why their profit contribution is 0. Now we will convert this data in a simplex table. Okay, so now standard form we have written, we have added one slack variable in each constraint. And what is slack variable? Slack variable represents the unutilized capacity of a resource. So for example, for resource number 1, whatever capacity remains unutilized, that is represented by s1. And for resource number 2, whatever capacity is unutilized, it is represented by s2, slack variable 2. Now when we start the solution, okay, when we draw this simplex table, first let us explain what is the structure of this table. See, x1, x2, s1, s2, these are the variables. Originally there were only two variables, x1 and x2, but after standard form, now there are four variables, x1, x2, s1 and s2. So now there are four columns for x1, x2, s1 and s2. These two rows, they represent the constraints. See, we have two constraints here, so therefore there are two rows. So number of columns are equal to number of variables, number of rows are equal to number of constraints. Now this part of the table from here to here, that C, X and B here, this square, that is called basis. This is the basis of the table, and any simplex table we should start from basis only. Okay, now when we start the solution, we should assume that in these two constraints, we will assume that values of x1 and value of x2 is 0. So this is our starting point. Okay, so now if we say value of x1 and x2 is 0, so this part will become 0 and this part will also become 0, and what will remain in the solution is only this, s1 equal to 80 and s2 equal to 96. Okay, so this is, we assume that at the start of the solution, so for this table, and we will give it title first simplex table. Okay, so you should remember that for the first simplex table, you should assume that x1 and x2 is 0 and only s1 and s2 will remain in the solution. Okay, now C, X and B. C stands for coefficient of the objective function. Now if you see the objective function, the coefficients are 8x1 20x2, 0s1, 0s2. So that we will write here. See, the x1 8, x2 20, s1 0, s2 0. So C stands for coefficient. Okay, now, so again same here, C or Cj, it is the same thing. C is coefficient, x means variable, and B stands for quantity, means what is the quantity of the variable. Now see here, how many variables are remaining in the solution now? S1 and S2. So we will write here, the variables are S1 and S2. And how much is the quantity? S1 is 80 and S2 is how much? 96. Okay. Now you can write the C value. For S1 and S2, what is the coefficient of S1 and S2? 0, 0. So S1 coefficient is 0 and S2 coefficient is also 0. So now our basis is ready. So always whenever you write simplex table, start with basis. Then we go to the constraint lines. Now see the constraint lines. Now here we will write the coefficients in the constraint lines. First constraint 2x1 plus x2. So x1 coefficient is 2 and x2 coefficient is 1. See, x2 means 1 into x2. Same way x2, then s1. So here again coefficient is 1 because it is 1 into s1. In first constraint s2 is not there, so s2 coefficient will become 0. Then we go to the second constraint 3x1, 4x2. So here coefficients are 3 and 4. s1 is not there, so s1 coefficient is 0 and s2 is 1 into s2. So s2 coefficient will be 1. Okay. So now our basic data is ready and now we will go to calculation of Zj. So for your reference, you can mention what is the formula of Zj. So Zj is equal to C column. It is a summation. It is a summation of C column into each column, each variable column. Okay. So it is summation of C column into each variable column. Okay. Now say for example x1. So we will find Zj of x1. So the C column is 0, 0 and x1 column is 2 and 3. So for x1 it will be 0 into 2 plus 0 into 3. So 0. So here Zj value will be 0. Same way for x2 it will be 0 into 1 plus 0 into 4. So again 0. Then next column is S1. So 0 into 1 plus 0 into 0. So again 0. And S2 0 into 0 plus 0 into 1. So 0. Now why all Zj's are 0 for this particular table? The reason is because C column is 0. So because since C column is 0, obviously all Zj values for this particular table will be 0. And this is called delta. Delta is called opportunity cost. So delta is for every column, delta is Cj minus Zj. So it is 8 minus 0, 8, 20 minus 0, 20, 0 minus 0, 0, 0 minus 0, 0. Okay. So now we have completed the first table. After this, we apply the test of optimality. Whenever you complete all the table and find the delta values, then you apply the test of optimality. And the test of optimality is the solution is optimal if no positive delta. It means when will the solution be optimal? Only if all delta values are either 0 or negative. If it is positive, it is not optimal. So now here we have two positive deltas 8 and 20. So we can write a comment here that positive delta therefore not optimal. Okay, it means this table is not optimal because we are having a positive delta. Okay. It means we have to go in the next table. One more table after this will come. So now for that, we identify first a key column. It means this table will now change and a new table will come. Now what will be the changes? It depends on the key column. What is the key column? So that is what we call KC. So first is KC calculation, and key column is equal to highest positive delta. So now 8, 20, two positive deltas, highest is 20, so we select this column. Okay, so this column we have selected. That is the column of which variable? X2. So now our KC is X2. Okay, so and this KC is called incoming variable. Okay, so you should remember that key column is the incoming variable. For the next table, this variable will enter the solution. Okay, so we have found the key column. That is, key column is the highest positive delta, and key column is the incoming variable. That is, highest positive delta for this table is 20. So our key column is column of X2. This key column is called incoming variable, means in the next table, this X2 will enter the solution. Now, if X2 is entering the solution, one variable has to go out. How to find that outgoing variable? That we will come to know from ratio. And the formula of ratio is quantity column divided by key column, or BI. Quantity column means BI column. So the formula of ratio is BI upon KC. This is the quantity column, 80 and 96. So now what we will do is, we will divide this BI column divided by respective key column value. So first ratio will be 80 divided by 1. That is 80. Second row, BI is 96, KC is 4. So 96 divided by 4. So 96 divided by 4 is 24. Okay, now we have got the ratio. Okay, now next is, just like there is a key column, there will be a key row, KR. And key row is minimum positive ratio. Okay, always remember, key column is the maximum positive value and key row is the minimum positive value. So now 80 and 24, so the minimum value is 24, so this is the outgoing variable. KR or key row is called outgoing variable. So one variable will enter the solution and one variable will go out, and that is the second line. So this is our KR. So we highlight that. Which variable is this? S2. It means X2 will enter the solution and S2 will exit the solution. So X2 is incoming and S2 is outgoing. Okay, now our table is complete, and this intersection value of KR and KC, this key column and key row, this is the intersection value. Mark it with a star, that is 4, and that is what we call as key element, or KE, that is equal to 4. Okay, now our first table is complete. So our KC, that key column is the maximum positive delta, incoming variable, that was X2 because delta is 20. Then you find a ratio, divide B column BI upon KC, 80 upon 180, 96 by 4, 24. Minimum ratio is 24. So this is the outgoing variable, that is the KR, key row. Intersection value is 4, that is called the key element. Now our table 1 is complete. Okay, now our table 1 is complete. We know what is KC, what is KR and what is key element. Now we draw the second table, and this is the second simplex table. Again we start with CJ, the coefficients in the objective function, they are same as 8, 20, 0, 0. Okay, those CJ values will remain same. Now what will change is the basis. Now X stands for variables. Now see, if you compare this basis, in this table, first table, the basis was S1 and S2, basis variable, the X column. But now in the second table, S1 will continue, so it will remain, but S2 goes out, so S2 will be replaced and the incoming variable is now X2. So instead of S2, now it will be X2. So our variable column will become S1, X2. And then we can write the C column. S1 C value is 0, coefficient is 0, X2 coefficient is 20. Okay, and now we have to find the new values of the table. So that calculation we will do now, and we will see here calculations for second table. first calculation is for KR, for key row, and its formula is new values equal to old values divided by K. Okay, this is the calculation of KR. Now the KR was the second row, so we will take all the second row values, that is 96, 3, 4, 0 and 1, and divide it by key element, and key element was 4. Okay, so 96, 3, 4, 0, 1, each value divided by key element was 4. So if we get the new values here, 96 upon 4 is 24, 3 by 4 is 0.75, 4 by 4 is 1, 0 by 4 is 0, and 1 by 4 is 0.25. These are the new values of the key row. Okay, and this is the second row. So these values, new values in this table, those new values will come now in second row. So here we will write 24.75, 1, 0 and 0.25. These are the new values of the key row. Why we have written in second row? Because key row was the second row. This is first calculation. And second calculation is for non-KR. Non-KR means other row. Okay, the remaining row, that is the first one now. And for that the formula is new values equal to old values minus, in bracket, KC value into new KR values. Okay, we will write this in a vertical format. First, we will write all the old values. The non-KR means the other row. This is the first row values 80, 2, 1, 1, 0. So we will write here all 80, 2, 1, 1, 0. Okay, 80, 2, 1, 1, 0 minus. Now in the bracket, KC value. Now see this first row 80, 2, 1, 1, 0. In the key column, the corresponding value is 1. Okay, so that KC value is now 1. So 1, okay, and it remains constant for all values. Because how much is the KC value, key column value in that first row? It was 1. So we have taken here 1 into new KR values, these values, new KR values. So we will write all these values here. So 24.75, 1, 0, 0.25. And when we solve this, we will get the new values. So 80 minus 24, 56, 2 minus 0.75, 1.25, 1 minus 1 is 0, 1 minus 0 is 1, and 0 minus 0.25 is minus 0.25. Okay, so these are the new values. And these new values now we will write in the new table in that corresponding first row, because we are calculating for first row here, so we will write in first row here. So it is 56, 1.25, 0, 1 and minus 0.25. Now the values we have got. So now the next step is calculation of Zj, and Zj we already seen is equal to summation of C column into each column. So that is Zj, summation of C column into each column. So now we will find here Zj's. So Zj value, see for x1, first column it is 0 into 1.25 plus 20 into 0.75. So 20 into 0.75, that will be 15. So here Zj value will be 15. Then x2, 0 into 0, 20 into 1. So 20 into 1 is 20. So Zj is 20. Then s1, 0 into 1, and 20 into 0. So 20 into 0 is 0, 0 into 1 is 0, so it is 0. And S2, 0 into minus 25, minus 0.25, and 20 into 0.25. 20 into 0.25 is 5. So here Zj is 5. So this is the Zj calculation. And then we calculate delta. So first column Cj minus Zj, 8 minus 15 minus 7, 20 minus 20 is 0, 0 minus 0 is 0, 0 minus 5 is minus 5. Now when we calculate delta, we apply the test of optimality. And what is the test of optimality? Solution is optimal when there is no positive delta. Minus 7, minus 5, so no positive delta. So you write in comment, no positive delta, therefore optimal solution. So solution is optimal, so there will be no calculation, no key column is there, and no ratio will come, so you cancel this. Now this table is over, and now we can write our final answer. And our final answer we will always get from the basis. Okay? So from here we will get our final answer from the basis of the solution. This is our basis. So now from the basis we will write our final answer here. From the basis you can see the variables in the optimal solution are S1 and X2, and their respective corresponding quantities are 56 and 24. So we will say optimal solution S1 equal to 56 units. S1 is a slack variable, means unutilized capacity of resource, and X2 is equal to 24 units. So this is the main answer, because S1 is a slack variable and this is the real variable. And then we can also find max Z value from here. C is the contribution or profit value. Profit of S1 is 0 obviously because it is a slack variable, and quantity is 56, so 0 into 56 plus coefficient of X2 is 20 and its quantity is 24, so 20 into 24, so max Z is 480. This is our final answer. Okay, so now our solution is complete.